Welcome back to Refactoring PaleoRose. This is PaleoRose. Now it's time to finish up our assessment and start moving on and fixing this code. So you may remember in the last episode, we just covered Xcode settings. In this episode, we're going to cover the remaining sections of this assessment, largely because the app is really simple. First up, dependencies and services. What are they? Well, they're anything that is not your own code. Other libraries, other services you might be using. Firebase is a good example. Those are all different kinds of dependencies and services. Now, when we look at our app, we'll find that we really don't have much. So if you look into the general settings for the target, you see that we have a number of frameworks, libraries, and embedded content. We have Cocoa, we have a security framework, and we have SQLite. That's it. We don't have any other services. We're not using anything special anywhere in this app. And that keeps things simple. But you need to be aware of any services or libraries that you're using because they may require special handling, special licensing, and all those sorts of things. Because we don't really have any services that we use, we really don't have a lot of secrets. The secrets that we do have include certificates. We don't want any certificates stored in our repo, for example. We don't want API keys stored in our repo. If we can find a way to inject those keys at build time or at runtime so that they're not in the repo, that is a good move towards security. But as it happens, we really don't have any. We can take a quick look though. Okay, now we're back in Xcode. Where would you look for secrets? Well, one is the info plist. Is there anything in here that looks like it is a key or a secret that we don't want to be storing in the repo? And there's nothing there. The other main place to look at is any xcconfig files that might be making configuration settings for us that contains important secret keys. But if we look in here, we have no xcconfig files. Great. One other good place to look is the application delegate. Well, here's the application delegate. It's pretty simple. Nothing there. But just to be sure, let's check the header. Nothing there either. So we have no secrets in the app, and that's great. In fact, there were some things that I would consider to be a secret in the app before I moved it to this open source project. I took all that stuff out, as it makes sense, to remove anything that is copyrighted and should not be released to the public. Removed all that. So that's taken care of. So let's go ahead and move on. File formats and languages. And what I mean by languages in this context is programming languages. So they're very much similar things. What file formats do we have? Do we have any Swift files, Objective-C files, any C files, C++? And indeed, what kind of language variants do we have? Do we have any unsupported or partially unsupported file formats in there? Like old nib files or old icon files. Now this one is a little bit more of an interesting story. So when we look into our project, we see mostly .m files and .h files, as we expect. We also will see zip files. But you may not be aware of it, but zips are often pronounced nibs. And the reason for that is a zip file is actually an XML version of a nib file. So if you looked into the content of a zip file, it's all XML. But originally, Project Builder and Interface Builder would use nib files, which were binary. In fact, when you build your app, the zip files, and I think storyboards as well, get compiled down to nib files. Do we have any nib files? Fortunately, no. And the reason why I say fortunately is Xcode can't read those files anymore. So I've lost a few projects because I was using Interface Builder that used nibs, and I did not update in time, and all those nib files are no longer available to use. So let's go through here and just see if we have anything in here that we want to pay attention to. For one, we got this entries thing. The file's not there. Just something we should take care of and get rid of. Going through the list. Nothing weird or unusual. So Xrode's help is a little bit different. It has an IDX file and a help file HTML. So this is actually a help book that uses an index to help people search through the library. A lot of independent developers don't build these anymore. They're kind of complex. They're kind of hard to build, but they're still supported. And in fact, I think Apple's own project still uses help books. So we want to update that, but it's basically HTMLs. So if you remember when we looked at the repo in GitHub, we saw that there was a number of HTML files, and this is where it's coming from. We also see some TIFF files. We don't want to have TIFF files in there. We don't want to have image files like that hanging around. We want to move to a more modern format and using an asset catalog. So that's something we need to move on to. Again, we have JPEGs, we have TIFFs. Probably don't want to do that, but here's an interesting one, icons files. Icons files used to be used by Xcode to set the icons for your app. It doesn't use them anymore. Luckily, it can still read them, it can still compile with it, but this is something we want to get rid of. We want to update the asset as well to reflect the name of the app, but we want to get rid of these icons files. Interestingly, we have the strings file. If you haven't done any localization, this is a way to set up different kinds of localizations. What the role of this particular file is, I'm not sure. It's meant to replace content inside the info plist, I think. But we will take a look at that at some point soon. So other than that, those strange things, that's the only thing weird. But I also mentioned not only just the different file types, the different language types that we have in here, I also mentioned what versions of the language. Objective-C actually has two versions. There's the original version and version 2.0. The original version, of course, went through a lot of changes over the years. I mean, it's rather old language. 2.2, Objective-C 2.0, made a lot of changes to make it more useful and to work with Arc better. The question is, which one are we using in our app? Why don't we take a look first at our document file. Let's go to the top, and we can get a good clue about what language we're using. So these property tags and these little descriptors in here, that is a sign that we've done some of this work in Objective-C 2. So these property tags will actually handle things like accessors, get the value or store the value for you. If you're using Objective-C 1, you would have to do that entirely manually. So we'll probably likely see, even though we have some Objective-C 2.0 stuff, probably see some stuff here and there that is clearly Objective-C 1. So let's see about pattern controller. That is starting to look Objective-C1. It's kind of hard to tell. There's not much there. Same with the preference panel. Now this dataset controller has no properties in it. Everything will likely be driven by accessors. Like here's an accessor. Set the valid to Boolean. Now it does a few things based on that, but that's an example of an accessor. Like this is another example, Objective-C1. Set predicate and get predicate. You don't have to do that with Objective-C2. So one of the key things that we've discovered now is that this application is a mixture of Objective-C1 and Objective-C2. That's not really a surprise. The app is old. A lot of it's probably Objective-C1, but some of it got modernized to Objective-C2 along the way. Let's talk about the UI system. Today, there's many ways to build a UI. There's interface builder approaches using xibs and storyboards. That's this graphical user interface where you build up your views. Secondly, there's programmatic ways where you write code to build your views. You're using UIKit or AppKit. There's also the programmatic way of building with SwiftUI, where you're writing your code programmatically, but you're using the SwiftUI library. You can also do programmatic interfaces with Metal or SceneKit, or even something else, maybe a third-party application like Unity or something like that. But one of the things you have to do is to decide which is your preferred system and stick with it. Now you may want to change it. It may be something you don't want, but then you need to take the time and the risk to convert an old system to the system you prefer. So for example, switching from xibs to UIKit or AppKit has an amount of risk to it. It's going to take time. It's going to take energy. And you can break all sorts of things when you make this conversion. So you can't make a change lightly. But you want to pick a system that you prefer, and then everything new should stick with that. And then anything old, when you have the opportunity, you can migrate over. So what is our app using? So we already kind of looked at this a little bit, but almost entirely the app is using xibs. Just to make sure we don't have any storyboards. So it's entirely, well, I shouldn't say entirely. It is primarily xibs. Now there's a few programmatic views in here somewhere. Let's see. Let's check this. This might be a programmatic view. So it's starting to look like a programmatic view. Yeah, there's no interface builder objects in here at all. So it's definitely a relatively simple programmatic view. So we have at least one example of a programmatic view, but most of everything else is storyboards, or excuse me, xibs. Next, memory management. We talked a little bit about memory management from time to time throughout working on this project. The default memory management system today is Arc, whether or not it's Objective-C or Swift. Now, you can turn Arc off for Objective-C, but I don't recommend it. It's very difficult to manage. But Arc is the standard right now. Arc, again, is automatic reference counting. So it's a way of keeping track of whether or not anything's holding on to a particular piece of memory. So if you have an object, every time somebody decides to hold on to it, its retain count goes up by 1. Every time something lets go of it, the retain count goes down by 1. If it ever gets to 0, then that piece of memory is released. For the old style, you would have to do this all manually. You'd have to mark it as retained, mark it as released, and then it would make those counts move. The implication of this change, though, is that you have to take precautions to make sure that the compiler knows what you want it to do. So that you might set the value, but you don't want the retain count to go up or down. Well, you have to tell the compiler to do that. Otherwise, you're going to have problems. If you have other languages in the app, you might have different memory management rules to deal with. For example, if you get into C, you have to do memory management differently in C than you do with Arc. And you should always check for any kind of signs of memory issues in the app. So why don't we do that? See if we have any memory management issues. Now, before I get too far, I just want to see if there's any holdovers in here from the old system. So let's look for the word retain. We have a few notes about retains, but they're largely in comments. That's good. What about release? Oh. Well, fortunately, this is an example of manual reference counting, but luckily it's been commented out. And this is one of the reasons why you don't want to keep this stuff around for long periods of time, because you start wondering why it's there. Why do we have an old style retain release in this code? And we have it in a couple places. Now that's a little bit different, but these are definitely things that shouldn't be there. But that's a sign of the old memory management system. It is possible we might have garbage collection in here. So one term we might want to look for is drain. Luckily, we don't see any of that. Now, let's run the app and take a look at our memory management situation. Here we are in the app. I'm going to do a very simple test by just creating a bunch of new documents. And then I'm going to close them all. Okay, let's go back to Xcode. Let's look at the memory. Ooh, that's not good. What we see here is that the memory stayed constant for a while the app was just sitting there. But as soon as I opened up a bunch of documents, the memory footprint skyrocketed. And then what we see is that when we deleted them again, the memory management didn't release any of that memory. What that likely is a retain cycle, where the app is holding on to stuff that it shouldn't be. And we don't want that. We want, when we create documents and delete them again, the memory to go back down to the base level for the app. So this is not a good sign. So we better make a note for that. I happen to know there's a memory leak there too, so we need to also fix that. Okay, I don't want to look at that anymore, so let's move on. All right, asynchronous code. Well, why are we bothering with this? Well, we kind of need to know what the paradigm for asynchronous code was in the app. It could be a lot of things. It could be async await now. We could use Grand Central Dispatch with dispatch queues. We could use really old threading. We could be using things like combine or react. And the question is, what is the preferred model? I personally love async await. But if you're in an app that's some other system, you may not be able to implement async and await right now. The issue is that you have the same problem with asynchronous code as you would with the UI. We have a UI in place. Hopefully it's working. We also have an asynchronous model that we're using, and hopefully that's working. But we may have a preferred system, but we may be stuck with an old system. And making that change presents risks in terms of time and in terms of reliability. If the system's working fine, you have to really question if it's a good idea to make that change. So the question is, what are we using in the app? So let's look for the word dispatch. Nothing. Async. Nothing. Combine. The word's there, but it's not combine. No React. No threads either. To be honest, writing multi-threaded apps back in the early 2000s was really hard. It's hard now, but it was really hard then. And quite frankly, there wasn't a lot of room for asynchronous calls. There might be completion handlers, but I think most of these are not necessarily going to be on a background thread. So these are all completion handlers associated with the view, which probably will be on the main thread. So you can see most of them are associated with sheets. So there may be some asynchronous stuff going on, but nothing that we're really truly controlling. So this is actually a problem. This app has no asynchronous calls at all. And we don't want that. We want to have a responsive interface. So we need to make that change. That was simple. What about a color and font system? What I mean by that is you can use colors and fonts in place anywhere in the app. You say, oh, I need a font here. I'll just say it's this font. But I find it's far more judicious and easier to manage if you have a system for your colors and fonts. You can consider those to be themes but those systems are there to make your color scheme and font scheme consistent throughout your app. For example, for color, you want to make sure you handle light and dark mode. Do you need accessibility, higher contrasts? Do you have any kind of organization to these colors? And importantly, are you using semantic naming? Are you naming colors based on their color? Or are you naming the colors based on their role? For example, if you want a background color, do you want to be white? Or do you want to be called background color? And at first, that sounds a bit weird. It allows you to set the background color somewhere. And then where you really define the background color, you can do somewhere else. So for example, Apple is doing that for you now with a whole series of semantic named colors. Now, the same is true for fonts. You have to do a few other worries with fonts. For example, if your font is not built into the app or built into the OS, you'll have to make sure that your fonts that you're using are legal and legally licensed. And like colors, you want an organization system, preferably a semantic system. So you're defining the font by the role. And for iOS, you want to make sure you support dynamic type. For macOS, you might want to give the user option to use larger fonts. And that will require some sort of system. The question is, do we have any such system for our app? Okay, here we are back in Xcode. Let's look for NS Color. Now here it looks like a bit of a color system, but it isn't. What this is basically a color array that's meant to loop between different colors. So when you're using the app and you want to create a new layer, it might automatically pick one of these colors. So that's not really a color system. So here we find, light color, that's not great. It's not going to support dark mode. Here we have a little bit of semantic naming going on, but it's not quite the same thing. It's basically the user is allowed in that diagram to set colors for lines and layers. And so once they set it, you just need to access it for each thing. So what's the stroke color, what's the fill color, etc. And other than that, there's really no color system in this app. And you might be thinking, well, that's probably fine, but the thing is we want to be able to update the interface easily. And without a color system where we're defining the colors for the interface is defining the colors for us, which we don't really want. So we need to come up with the color system. What about fonts? Well, it's pretty much the same thing. We use customized fonts where we are being defined by somebody else. For example, the user might define a color or a font for different parts of the app, but when we're actually using the app interface, the app widgets, we're not really doing anything. So we don't have any kind of system for that. Localization. Localization should be required for all user-facing strings. That doesn't necessarily mean supporting other languages. What it means is supporting the ability to support other languages and different regions. Some regions may format numbers differently, for example. They might want a different language. We might want to support that language. But if the app isn't localized, the decision is going to get put off because you cannot easily make those changes. And once the app is in place without localization, again, it's time and risk to go back and change everything. So you want to have that first as you're building the app, because once you've built the app and you haven't done this work, it's going to be hard to get it in later. And it's going to be hard to convince people to do it. We can look at the app, but I guarantee you there's no localization. Okay, here we're back in the app, looking for localizable strings. See description keys, which is nice, but we're not seeing any localizable strings at all. In fact, if you remember when we looked at the info for the project, there's some automagic localization going on in some of the zibs, but it's not really localized. So this is not a great situation. But there is one localized thing in the app. If you remember, we looked at it earlier. See if I can find it again. This info plist strings file is localizing some of the strings in the info plist. I'm not sure if it really needs to be done this way, but it's better than nothing. Okay, so we're not happy with that. The last category, accessibility. Is the UI accessible? Where did we do accessibility right? Accessibility not only includes voiceover kind of technology, but also visual elements. Can the user see that are we using the right color scheme? There's all sorts of things associated with accessibility, and it's difficult. We want to do the best we can, but if you built the app before you added accessibility, you still have the same problems. It's expensive to go back and fix it, and it's also very risky to go back and fix it. In this modern era, accessibility is becoming a requirement. So if you don't build it the first time right, you're going to have to build it the second time. So what about our app? So there may be some built-in accessibility in the zibs, so I'm not going to look at that right now, but I can guarantee you there's no accessibility built into this app. And in fact, that plot is going to be difficult to make accessible too. There's no doubt that making things accessible is difficult, but we need to do it. So one of our goals should be, whenever we touch any UI, we need to make it accessible if we can. It's not easy, but I think we can do most of it. What cards can we make out of this? Well, we want to investigate adding asynchronous code. I can learn to spell. So we want to do that. We want to spiff up this project quite a bit. But really, it's an under-investigate because we're not going to go through the app and change it everywhere to add asynchronous code. But we want to make code asynchronous where it makes sense. So we need to investigate. We want to add a color and font system. You can make it a theme or something else. I generally recommend that you have a system that is using semantic naming. We want to localize all user-facing streams. And finally, this is the high-level things that we found. Of all of these, the one that worries me the most, start off with, is this one. Retain cycles and possible leaks going on in the app. So next time, we're going to go after that. We're actually going to start making changes to code. I hope you had fun looking at this real quick. Again, thank you for coming, and I wish you the best of luck.